So the graphs of my exponential functions all look basically the same. It doesn't matter whether it's 2 to the power of x, 10 to the power of x, they have the same kind of shape. If we think about any number, it doesn't matter what it is, sort of 2 to the power of 0, 3 to the power of 0, 4 to the power of 0, they're all equal to 1. So my intercepts all occur at 0, 1. Think about x negative numbers, 2 to the minus 1, 2 to the minus 2, 2 to the minus 3. Well, they're not negative numbers. That's just 1/2, 1/4, 1/8. So what it means is if x is negative, my number gets really small. If x is positive, 2 to the 1, 2 to the 2, 2 to the 3, etc., 1, 4, 8, it gets bigger. So the only difference between a 2 to the x and a 10 to the x, if I was to bring that 10 to the x in here, it'd be a lot steeper and get a lot smaller sooner. All right. So key features are intercept is at 0, 1. Okay, they do not cross the x-axis. There are no x-intercepts, which means it's a horizontal asymptote at y equal to 0. So in other words, at y equal to 0, I have an asymptote. Okay, we need to sketch that. The domain for the graph is R. We can use all values. So there's no restriction on the x values. The range of the graph is R plus. So they're always positive values, but never 0. Okay. So we can see there that they're sort of increasing functions. The bigger the value of A, the steeper the graph gets. All right. So if we continue that along, let's sketch our graphs. Sketch the graph of 2 to the x minus 1. So if I just sketch my standard graph, if that's 2 to the x, what happens here? The negative 2 shifts everything down 2 units. That negative 1 shifts everything across 1 unit. So this horizontal asymptote that is there for the original graph, it gets shifted down 2 units. And that point there, a positive 1, comes down to negative 2. So it comes down negative 2 units to negative 1 and moves across 1 unit to there. So my graph will look something a little bit like that. So that point there is now that point there. Okay, showing the asymptote and stating the domain of range. So the domain of my graph is R. The range of the graph, well, it's going to be from negative 2, not including, up to positive infinity. Okay. Same thing. Let's have a look. I might do the graph over this side this time. So I might just rewrite my equation to be f of x equals negative 3x minus 1 plus 2. So straight away it's up 2 units, right 1 unit, and a reflection about the x-axis. So if I do my standard graph, okay, what's it going to look like? We're going to reflect it. So instead of 0, 1, it's at 0, negative 1. 1 unit to the right, all of a sudden it's at the point 1, negative 1, and then up 2 units to there at the point 1, 1. Okay. So the reflection, what's the reflection going to do? The reflection is going to make the graph look this way. Yeah, and then we're going to shift it all up and across. So my horizontal asymptote goes from 0 to positive 2. So we'll call that y equal to 2. I'm going through that point there. So we know the shape's going to be that way. What I'm not too sure about is where are we on the X and Y intercepts. So again, if I happen just to put X equal to 0, if I put X equal to 0, I'll get Y is equal to 2 minus 3 to the 0 minus 1. So 2 minus a third. So it's a positive value. So my intercept is about there somewhere. So my graph will look like that. Okay. We'll spend more time finding the X and Y intercept, but I think the Y intercept is a nice, quick, easy one. And it helps us to find the values. State the domain of range. Domain, again, is always R. What's the range of this graph? Well, we get as high as 2 down to negative infinity. All right. I'm sure we can check that on our CAS. All right. So have a go at that.